Hey guys, welcome back to my channel. So today I will show you how to answer this one. We need to use about interpretation by substitution. So we can see that this is about s to the power of 4. We can put s where everything to the power of 2. So I will put about u equals to s squared. Later that we need to do first the derivative for the both sides, and we have to ask the s because we don't have number 2, so we need to divide both sides by number 2. Next, we need to change the bounds. When s equals to number 0, so I will put number 0 on here, and we have u equals to number 0. When s approaches to positive infinity, this one they will go to positive infinity of u. So number 0 we don't change anything. This one we don't change anything. This one we change for u. The s we change for this one. Next, we can use about interpretation by trigonometric substitution. So I will put about u equals to 1 over the square root of number 5 tan t, because if I put this one gone here, we have 1 over 5 tan t squared. Number 5 and number 5 we cancel. 1 plus tan t squared, that is about secant of t squared, and later that we simplify by du. Now we need to do first the derivative for the both sides, and you got like this. Now we need to change the bounds. So when u equals to number 0, so I will put number 0 on here, and we have t equals to number 0. When u approach to positive infinity, so this one we put positive infinity on here, and you got about t equals to b over 2. So number 0 we keep the same, positive infinity, that is about b over 2, about u, that is about this one, du, that is about this one. So this one, that is about 1 over 5 tan t squared. So number 5 and number 5 we cancel. So this one, that is about secant of t squared. And now we simplify. You got like this. So I will put the square root of number 5 go outside. The integration of dt, that is about t, and I will put the bounds from 0 to b over 2. And now we have the final answer. This is the end. Thank you for watching.